Well, hello and welcome YouTube. Mr. Robinson back with yet another brand new exciting video, all math-based of course, and today's focus is going to be on integers, integer addition and integer subtraction. And actually, I'm going to be doing this very basically. I'm going to be using single-digit addition and subtraction of integers. Now, why am I doing a video like this? Because I have an Algebra 1 class, or working on Algebra 1 stuff, and I want to avoid the careless mistakes of when you isolate your variable and you're trying to add and subtract things over, that you don't accidentally go the wrong way with subtraction. And I know that there's easy, basic addition and subtraction, and that's the point. I want to make it all appear, or I want you to think about them as being all basic. And there are reasons that people mess these things up, and I'm going to not really talk about that, but I'm going to talk about the right way, or a way, to really get you to help yourself. So in order to do this, what I'm going to do is, I have a number line here, just ignore that for a moment. I'm going to be working on several, what should I call them? Things for you to really clue on as I'm talking. It depends on what I'm doing with it, or several conditions that I'm going to be laying down so that whenever I say them, they kind of make sense as I do them. Number one is, and I'm using letters just for a general thing. Number one is, when you add a negative, that's equivalent to subtracting. And when you subtract a negative, that's equivalent to adding. What I'm doing here is it's giving me a little bit more ease of mind, no parentheses, no two operations, and I know exactly what this operation is right here. And I'm going to be using this not just for making it cleaner, but also there's something to what a minus is and what a plus is that's going to help you if you kind of follow this mindset. The other thing about this is that, I want you to really think about, if I do have a problem presented like this, I'm actually going to rewrite it in this form. Okay, so that's the first thing that I want to lay down for you to know. Second thing is the commutative property of addition, which states that if I add two values, or any number of values, if they're being added, I can rearrange what's being written, and I'll still get the same result. If I do 4 plus 1 and 1 plus 4, I get 5 regardless of the way I do it. And it doesn't matter if these numbers are integers, positive, negative, doesn't matter if they're irrational. You can always do it for them as long as you maintain the sign. If b was negative, b stays negative, stuff like that. But for simple purposes, 4 plus 1, 1 plus 4, they both get 5. This is also true for multiplication, but I'm just doing addition. This is not true for subtraction. 4 minus 1 and 1 minus 4 are not the same thing, but there's something to them that we're going to be using together that we might have something to talk about this with. We'll see. Third thing that I want to bring to light is just the idea that distribution of a quantity can lead to bringing that negative into both of your terms like this. I don't yet know if I'm going to be writing this out for any particular reason, but I'm going to be making mention of how I can use this concept, and then I might write this down later. So those are the three things to just keep note of when I'm doing some of the stuff here. And I really want to talk about these first two, just right off the bat here, the plus, negative, minus, negative turning into these two. The reason I want the minus and the plus like this is so that I know exactly which direction I'm going. See, a lot of people, when they do plus or minus, when they think positive or negative, they're really thinking of signs. You think positive is a sign, positive 4, the sign is positive, negative 4, the sign is negative. I'm going to think of it in a different light, though. I want to think about positive and negative, plus and minus, as directions. We think of north, south, east, west as directions. I think of in front of or behind or above or below as directions. I think of those kinds of things. Why can't a number line have directions right and left? I think they should. I think plus and positive should be right, and minus and negative should be left. And it will really help when it comes to the problems that I do and how we can make those easier for us once you understand that plus and minus and positive and negative really are just directions on a number line. So that's how I'm going to clue into this number line and make use of it, and I'm going to be drawing out cases and color coding them, kind of helping you along the way with that. So just keep in mind plus, minus, right, left. Okay. So there are specific cases here that I'm going to be showing you on a number line visually, and then I'm going to be writing out examples of them, and we'll evaluate them and connect some things together when we can. I'll try to use the same expressions, just two single-digit numbers added or subtracted, positive, negative. Okay, case number 1. I have a positive number, right of 0. I have a positive number, and then I add assume another positive number. I add another positive number. So let's say those cases are like 5 plus 3, 8 plus 2, 4 plus 1. Things like that. Okay, that's case number 1. Case number 2, and I'm just going to change colors. I have a positive number, and then I subtract a number that's not quite as big. Okay? So we're talking about, look at these numbers here. We're talking about like 5 minus 3, 8 minus 2, and 4 minus 1. Now when I say not quite as big, I mean that if you subtract itself, it would go down to 0. And if you subtract more than it, well, that's probably, we're looking at the next case after that. Case number 3, as I just mentioned. I'm going to take a positive number, and I'm going to subtract something larger than it. Okay? Let's take just these numbers here, and let's reverse them. This is why subtraction is not commutative, because these aren't the same thing. 3 minus 5, 2 minus 8, 1 minus 4. Okay? 3 more cases to do, and there are actually 2 other cases alongside the way. I'm going to refrain from talking about them, though. But, okay, case number 4. Let's get a negative number. Let's get a negative number left, negative minus left, and we subtract left. Okay, case number 4. So like negative 5 minus 3, negative 8 minus 2, negative 4 minus 1. Case number 5. I have a negative number, and I add a number that's not quite as large as it. Okay, so there we're thinking of things like negative 5 plus 3, negative 8 plus 2, negative 4 plus 1. Right. And finally, case number 6, when you have a negative number and you add something that is larger than it. So thinking about something like negative 3 plus 5, negative 2 plus 8, and negative 1 plus 4. And again, keep in mind, I'm not doing the plus negative minus negative. It's like, assume I had already turned that into these ones here. Okay, so those are 6 different cases there. Now there are 2 other cases to refer to, and then 2 others that would be redundant. Okay, the 2 other cases that I would be referring to are if you have something like a positive number, and then you subtract something that is exactly its size, in which case I'd land on 0. Or a negative number, and then you land on something that is exactly its size, in which case you'd land on 0. I'm not going to talk about those ones, but you should know them. Instead of, again, going the wrong way, we want to make sure we go the right way. But again, just considering those cases, I want to really look at the ones that affect, is the answer positive or negative based on what's there. Okay. There are 2 other cases that end up showing redundancy, and they are the ones where, notice how subtraction, I ended up switching big with small, and from negative to plus, remember from left to right, I ended up switching numbers, big to small. But on these ones, the negative and the minus and the positive and the plus, I never changed. I never wrote somewhere like 3 plus 5 and 2 plus 8 and 1 plus 4. Well, this is because of that commutative property I was referring to, this guy right here. The commutative property states that I can rewrite these and these would work out. And then the other one with the negatives, this guy, as I drag them all up, this is kind of in reference to the other ones. Notice how a distribution of a negative can lead to a negative and a minus. Well, then I could also rewrite these things right here as the opposite of 5 plus 3, and the opposite of 8 plus 2, and the opposite of 4 plus 1. And what you have inside here is addition, which I could swap, because commutative property, and then I could distribute the negative, and I'd be on these guys right here, and again, they are the exact same thing as what I'm looking at. If that didn't make sense, that's fine, because what we're going to look at next is how we can make use of a number line and directions, positive, negative, plus, minus, to get a result. So this was a generic number line for me to make sense of those things and use things generally. I'm going to go ahead and copy these, and I'm going to paste them to my next slide that has a more specific version of a number line, like this one here. And hopefully I stay kind of within my bounds of negative 10 to 10 as I made these problems up. Okay, first one's in black. These ones, look, we know what 5 plus 3 is 8 plus 2 and 4 plus 1 are. But I do want to make sure that you get how I'm going to be doing the rest of them by making sense of these and saying you know those answers, so you trust my guidance. keeping in mind there's no positive sign in front of 5, 8, and 4, but you know that 5, 8, and 4 are positive numbers. So what I said before about plus meaning right and minus meaning left is going to be used right here, right now. Positive 5 plus 3. From 0, everything's from 0. We're going to go right 5, start on 5. Plus 3, we're going to add 3. That's where we get 8. I can count 1, 2, 3 literally, and I do get 8 from that. I start right, I go right. Positive plus right. Yes, right. Okay. 8 plus 2. I start on 8, and I go right 2. I'm on 10. See what I mean? I start right, I finish right, I'm going right. Picture that on a number line. I start to the right of 0, and I'm going farther away from 0 to the right. This is important because when I start to do some of the other problems, you want to understand how that direction works if you're having trouble with it. Last one, start on 4, go right 1 from 4. I do land on 5. I'll save you with that one there. Now I want to jump into these ones actually, the next case with the negatives, because it does lend to the idea of these pluses right here. And then I'm going to make a tie-in into both of those and how they work, like as you saw before. Negative 5 minus 3. Negative meaning left, minus meaning left. That sign means left. Left of 0, go to the left direction. Okay. So negative 5 is right here, left of 0, and I go left 3. 1, 2, 3, and I land on negative 8. I use the number line to help me get that answer and try and refrain from accidentally getting an answer of, say, negative 2. There are a lot of people who will write negative 2 as that answer because they think of 5 minus 3, and we'll get to that later. Negative 8 minus 2, start 8 left of 0 and go 2 to the left. Minus means left, and I go left 2 and I get negative 10. And then negative 4 minus 1. Start at negative 4, go left 1, and I get negative 5. Okay, let's focus on those 3 sets first. We have the positive pluses and then the negative minuses. Now, keep in mind what kind of happened positive pluses. And again, I know that you get it, but let's recap. Positive plus means we start at a positive number to the right of 0, and as we add, we go further away from 0, which means our number, not the sign, but the number gets larger, and we're going farther to the right. It's something that you get, but let's do that with the negative minus as well. A negative minus means you start at a negative number which is left of 0, and as you subtract, you continue going left. Going left means going farther away from 0. It's like going east and then going further east, or I guess west if you're talking about negative. But it's like, going west and then going further west. You're going farther from your previous point. And I know that for some of us, minus means difference of things, and there is a difference in that thing. But it's not just that number 5, it's a negative 5. So as we look back at our numbers here, we had negative 5 minus 3. And again, negative 5 meaning left of 0, negative 3 and minus 3 farther away from 0 to the left. We are now 8 to the left of 0. Our number got bigger negatively. It's a large negative number. It didn't get closer to 0. So 5 plus 3 and negative 5 minus 3 kind of give you the same result. They both have an 8 in it. 8 plus 2, negative 8 minus 2 both have a 10. And 4 plus 1 and negative 4 minus 1 both have a negative 5. Both have a 5. So there must be kind of a connection between the ones that are being added and are positive and the ones that are being subtracted from negative. And there is. They're both trending away from 0 in their respective direction. And that's kind of what I want to point to. Minus just means left, plus just means right. And I know we don't have pluses in front of here, but there is an implication that these are pluses. If you need to write plus in front to help you each time, more power to you if you do. I suggest you try and refrain from it because you're going to have to do it for the rest of your life if you do. And that's just something, let's kind of avoid that if possible. Plus right, minus left. So how can we do that for ourselves and make sense of that? Well, number one, you can say that out loud. You can say it in your head, left 5, then left 3. Or just come to terms with the concept of same direction, get larger. Same direction, get larger, same direction, get larger. And how does that help us? Well, I said I want to make sure that everything we do is basic. And I don't mean make it easier. I mean that everything we do is to something that we know how to do well. We know basic addition like those 3 that you saw. By basic addition, I mean a positive plus a positive. Okay? That's what I want us to think about. So when you have something with a negative and then a minus a positive, clearly, because I'm not talking about minus negatives. I said I'd not do that. If we're talking about a negative and a minus, that means we're going to get bigger in the negative direction. So what I recommend you do, and you don't have to write it like this, but I want you to think about this. What I recommend that you do, besides that left nonsense, is when you see this, tell yourself two things. Number one, your answer is going to be negative. Make sure you remind yourself that. Your answer is going to be negative. Number two, this is like addition. Negative 5 minus 3 is like 5 plus 3. Only the result is negative. So again, negative 5 minus 3, and this goes back to that thing I said I was going to write, is like 5 plus 3, only the result is negative. So you saw this thing before, distribution, on the previous slide here, right here. They're written in the other order. But negative 5 minus 3 is like the opposite of 5 plus 3. Do you have to write this? No, gosh, not at all. But treat it like it. Not subtractions like addition. Starting left and going further left is like addition because the numbers are getting bigger. As long as you can tell yourself numbers are getting bigger, think that's like adding. Okay, so that's kind of what's happening there. It's like addition, only it's negative. So when we run into another problem, let's do this problem. I'm not going to do single. Let's do double digit. Let's do negative 22 minus 16. That's like, so I start left, I go further left. Numbers getting bigger, that's like addition. So let's do 22 plus 16. What is that? I want you to think about it. 22 plus 16. Think about it. Got it? Yes, you know how to do that one. So we get 38. Is the answer 38? Close. I mean, not close because it's 76 away. But writing 38 is a good start. But left, left, left. Negative, minus, negative. Negative 38 is the answer. It's addition. But the answer is negative. Okay. Same is true for these other ones. It's addition, but the answer is negative because you go the same direction. You go the same direction. All right. So those are those cases there. Let's look at these other cases. 5 minus 3, 8 minus 2, 4 minus 1. 5, 8, and 4 being positive, being right. So like 5 minus 3. I start right, and I go left 3. 1, 2, 3. We know 5 minus 3 is 2, but you're getting a visual of it. Start right, go left. Now remember, I did this on the number line as well. Start positive and subtract a number not quite as big. So, excuse me, my result is still positive. 8 minus 2 gives me 6. 4 minus 1 gives me 3. As you know, with the number line, we'd be doing the same thing. That's a version of basic subtraction. And again, just by basic, I mean that the numbers, the first number is positive, the next number is smaller, and subconsciously, you are comfortable with saying that the result is positive, and there's nothing that's going to be going in the way of what makes it kind of a difficult concept. Because the ones that become difficult are all the other ones that you're about to see, one of which I'm going to kind of rewrite a different way. Is it this one? I think it's this one, this next one. And the other ones you're going to do a little, something else like that, one I did in blue. So the next ones I want to take a look at right here are, oh no, it's not the next ones. Let's do, I'm trying to think of what order I want to do this to make most sense. I'm going to go with the bottom right ones to start, because you're going to see all these ones are going to have something in common, but these two are especially going to have something in common here. Okay, negative 3 plus 5. Let's go ahead and look at what it does on a number line. Okay, start at negative 3, which is left, and you go right 5 because they say plus. 1, 2, 3, 4, 5. So this gives me, boom, 2. Negative 3 plus 5 is 2. Negative 2 plus 8. Negative 2 plus 8, we start at negative 2, and we go 8 to the right, because plus is right. 1, 2, 3, 4, 5, 6, 7, 8. We land on 6. Now, again, I'm not asking you to actually do a number line. I want you to picture what's happening, though, and I want us to try and figure out what we're going to be doing for negative 1 plus 4 without literally counting it. Don't count. I know you're trying to count it right now. Don't do that. So let's look at what we have so far. Negative 3 plus 5 is 2. Negative 2 plus 8 is 6. What are two things I can think of? Number one, I got positive answers in both of them. And you kind of know this because I came up with the examples because I did that generic number line thing that they result in positive. That's fine. But number 2, we're getting the same answers here as we got over here. 5 minus 3 and negative 3 plus 5 both gave us 2. Now, because they're both the same terms, 5 and 3, and because they both involve one negative sign, does that mean these always yield the same answer like this? The answer is yeah. Think about this as a number line again, or you in physical space somewhere. If I ask if 2 people are standing like right next to each other, like one behind another, and I ask one of them to walk 5 to the right, and then walk 3 to the left, and then I ask this other person to walk 3 to the left, and then 5 to the right, it shouldn't matter which order you do these things in, the end result will still be the same. You're going to end up in the same spot. It doesn't matter if I walk 5 right then 3 left first, or 3 left then 5 right first. As long as I don't walk 5 left then 3 right, I'm going to end up in the same spot as these other people because I still walked right the same amount as they did, and I walked left the same amount as they did. I just did it in a different order. And that goes back to that idea of commutative property. So let's look back at the fact that 5 minus 3 and negative 3 plus 5 are the same thing. Why are 5 minus 3 and negative 3 plus 5 the same thing? Well, this is where I said that I was going to be turning everything into minus. This is where that plus negative can really help. 5 minus 3 is 5 plus negative 3. Addition of a negative is subtraction, so subtraction is addition of a negative. And believe it or not, some teachers actually teach it this way. They want you to treat everything as addition and make the sign what it's supposed to be. Like the 5 is positive and the 3 is negative, and when I add them, blah, blah, blah. But, take a look at how this connects very well to the commutative property that I wrote earlier. A plus B equals B plus A. I can reverse the order of these things, I can add them, and they still become the same result. That's what this is. This is commutative property right here. All right? This is commutative property right here. I'm going to say it one more time. This is commutative property right here. Doesn't matter that B is a negative number. I'm still adding. And B remains negative. Left 3, right 5. Left 3, right 5. B is still negative. So I'm exercising my commutative property to make the most sense of it. Now, am I actually going better from this to this? No, that's harder to do. I think we all agree that for everything we see right here, 5 minus 3 is the easiest one to do. So what am I trying to get you to take home with this whole portion right here? If you have a case where you have negative and then plus, left and then right, and if that number is going to be exceeding 0, right? We start here and we end up farther away. It shouldn't be landing on 5, but just the idea. We start left of 0 and we end up going farther away. Excuse me, not farther away. We go past 0 and into positive land. You get 2 things to tell yourself here. Number 1, the result is positive. Number 1, the result is positive. Negative 3 plus 5. Left 3, right 5. I'm going to end up farther right then left. I'm going to end up positive, not negative. Okay. Number 2, because I started by going left and then I'm going right, I'm not going to go as far as I would have if I went right and then right, if you know what I mean. Remember 5 plus 3? 5 plus 3 was 8. I started right. I went further right. That's like addition, because you're going in the same direction both times. But if I go left 3 and then right 5, I'm going opposite direction. So I'm not going to go as far as I would have if I went right 3 and then right 5, or right 5 and right 3. I'm reversing direction, and although I surpassed 0 and went positive, I didn't quite go as far. I didn't go as far as 5 away from where I started. If I start here and I go left 3 and then right 5, I'm only 2 away, right? That's where you get an answer of 2. That's not even as far as just starting here and going right 5. So I've hit a difference between my 2 numbers. So when you run into a problem that involves, once again, a negative and a positive of any sort, and we're going to look at it with these 2 as well. Let's first talk about these 2 sets. When you have the positive number bigger, number 1, your result will be positive. Number 2, the result will also be a difference. It's like a subtraction. Difference is subtraction. difference is subtraction. So the reason I state that is because in case you don't end up rewriting it. Now I'm going to rewrite it for this particular one, negative 1 plus 4. Negative 1 plus 4 is equivalent to 4 minus 1 because it's like 4 plus negative 1 because commutative property. You know what? Let me say that one again. Let me do the 4 minus 1 afterward. Negative 1 plus 4, I went left and I went right. I end up farther right than I'm left. The result is positive, but not quite as far as I would have gone. I know this sounds confusing because I don't think you're going to say what I'm saying, but if you hear what I say, I think it's going to make sense. Go left and right. My result is positive, and it's a difference. It's not a sum. So I want to do basic subtraction with it, knowing that it's positive. Negative 1 plus 4 is like 4 minus 1. Okay? The result is 3. Just like this one's result is 3, because it was 4 minus 1. So what do I recommend for these kinds of problems where you have negative small plus big? Rewrite it so it becomes big minus small. That's the basic thing to it. If you know commutative property, you'll be fine with going the other way. Just say it's just like subtraction this way, only the answer is positive. It's just like subtraction. It is subtraction. Heck, I'll do that. Sorry for making that kind of little disjointed, but hopefully you're making a little bit of sense of that. Okay, these last two can throw in a little wrinkle as well, and some people are better with one versus the other. I'm not quite sure which, so let's just look at the ones in green. 3 minus 5. Well, let's try and talk about this kind of a little bit less with the number line. I'm not going to be playing counting games. But 3 minus 5, 2 minus 8, 1 minus 4. Now that you know it's small minus big, tell me or tell yourself whether you think the result is going to be negative or positive. That's the first thing. You got it? All right, so the result is going to be, say it. You said negative, didn't you? Good. So the result's going to be negative, unlike these ones which were basic subtraction. And I think you'll recognize what's basic subtraction because subconsciously I think you tell yourself big minus small. Boom. Easy. Easy. And not, some subtraction's harder. But big minus small is the best version of subtraction you can give yourself. Small minus big, you already tell yourself, uh-oh, it's a little confusing because small is positive, big is negative, so my result is going to be negative. If you can tell yourself the result's going to be negative, that's a good first start. Now, what is 3 minus 5? Starting from 3, we go left 5, we land on negative 2. 2 minus 8, start from 2, go left 8, you land on negative 6. And start from 1, you go left 4, we land on negative 3. Okay, so let's try and tie in these numbers, these answers, with the result that we have, say, right above. 5 minus 3 is 2, 3 minus 5 is negative 2. 8 minus 2 is 6, 2 minus 8 is negative 6. 4 minus 1 is 3, 1 minus 4 is negative 3. Is there a pattern that you see? We all see it. The absolute value is the same. We get that 2, we get that 6, and we get that 3, but one result's positive, one result's negative. Which results were positive? When we did big minus small. Which results were negative? When we did small minus big. So when you see something like 2 minus 8, you might try and throw yourself in a wrinkle and literally try and do that subtraction, if that makes sense. But I say you just do two things instead. Number one, tell yourself the result's going to be negative. You know you're subtracting a bigger number, so result's going to be negative. Just keep that lodged there. Just remember that. Number two, because the absolute value is the same as the one with the basic subtraction, let's do basic subtraction. Remember when we did the minus, negative, left, I said let's think of it as addition. Let's do basic addition. This one, small minus big, let's do basic subtraction. Let's make it look like big minus small. The difference is we just got to tell ourselves the answer is negative. So going back to these problems again as we look at them, instead of doing 3 minus 5 is like right 3, left 5 or whatever, tell yourself, okay, negative answer, but let's do 5 minus 3. Let's do 5 minus 3. This is like doing 5 minus 3, but what? But the result is negative. So 3 minus 5 is like 5 minus 3 with a negative result. Do you gotta write this? No, I don't recommend that you do write that, but I want you to see the tie-in. Distributing this can lead you into that if you know what you're doing with commutative property, role reversal, all that kind of stuff. It's like doing the subtraction. You know how to do 5 minus 3. And I'm giving you that credit. I want you to tell yourself that you know how to do that and trust that you're better with that. And you want to use it that way. That's really going to get you over that hump. Same with this one. 2 minus 8? That's like 8 minus 2. But what? The answer is negative. So 5 minus 3 is 2. The opposite of that's negative 2. 8 minus 2 is 6. The opposite of that is negative 6. So let's hide this answer. You don't know what it is. You don't know what it is. 1 minus 4 is like what? 4 minus 1, but negative. What's the answer? Negative 3. So 1 minus 4 equals negative 3. Not by using a number line. Not by using a number line, but by using basic subtraction. And keeping in mind how sizes of quantities work there. Okay, the last one, and this is really up to you how you want to go about doing it. So I am going to make use probably more of the number line again, and then I want you to think about how I want to play that next. Let's just go and undo all that I just did there. And we're good. Okay, so the last set, the ones in purple right here, negative 5 plus 3, negative 8 plus 2, and negative 4 plus 1. All right, negative 5 plus 3. We start at negative 5, and plus means right. So we're going to go right 3, and we land on negative 2. So the answer is negative 2. Now let's stop right there, and let's already look at what this ties in with. All right. You might say, oh, it ties in like this one. So why don't I rework negative 5 plus 3 into 3 minus 5, which is like 5 minus 3, but negative, so it becomes negative. No, I think that's a little too much. But when it comes to negative 5 plus 3, this is where that left-right stuff kind of matters, like on a number line. And not that you draw a number line, but if you visualize one, it'll help you understand whether, number one, your answer is positive or negative, and number two, whether you should think of this like addition or subtraction. Remember, that's all I'm doing with these problems, determining whether they're positive or negative, and whether I should add or subtract, based on whether they go left, further left, right, further right, left, then right, or more, so over, all that stuff. That's what we're doing on each one. Negative 5 plus 3, larger negative, smaller positive. Larger negative, smaller positive. Large left, go far left, not quite as far right. So what do we know? We know that our answer is going to be negative. We also know that our number's not getting bigger. I mean, it's getting close, it's going further, it's trending toward positive, but it's not getting bigger. The absolute value is 2. 2 isn't as big as that 8 that you saw in some other answers. See how this was 8 and this was 8 using 5 and 3? This one only gave me a 2, a negative 2, but it gave me a 2. Like these ones gave me a 2. Because all these end up being a difference because you go one direction and then the other. And that's why the signs are so important. It's not about being positive or negative with plus and having plus or minus. It's about, are the signs the same? These are plus or positive, plus, negative, minus. Signs same, go farther. Bigger numbers, it's like addition. Positive minus, negative plus, positive minus, negative plus. Opposite directions, diminishing our values, one size larger than the other determines positive or negative, but the result is like a subtraction. It's like doing 5 minus 3. And I'm saying 5 minus 3 because that's the most basic version of subtraction we can get here. So when I have negative 5 plus 3, I'm thinking two things. Number one, the result is negative. And number two, because it's smaller, because we're not going farther away from 0, we're either trending toward or we went over 0, it's like subtraction. It's like subtraction. So do the easiest subtraction that you can for it. 5 minus 3 is 2, but the result is negative. Let's try it with this one. Negative 8 plus 2. Opposite directions. The minus plus. Opposite directions. Negative is bigger, so we know the answer is going to be negative. Because they're opposite directions, it's going to be smaller, so it's like subtraction. This is like 8 minus 2, but we're going to get the negative answer. So that becomes negative 6. Okay. I know, I recognize the video is getting long. This is weird how long this is as you look at these. And I'm going to do some problems after this that are going to be rapid fast. But this is what you want to trend toward. Find your way on a number line and get a perception. Are you adding or are you subtracting? Is the result positive or is the result negative? That's all that's being asked.
There's another question before it, such as, if you're adding a negative, we write a minus. If you're subtracting a negative, write a plus. -4 plus 1. The result is negative because the negative number is bigger. Opposite direction, so it's like subtraction. Let's subtract 4 minus 1, which is 3. The result is -3. That's how fast I'm going to do the other problems here. So there's the nutshell of that stuff, okay? The nutshell, once again, and I know that you're getting overwhelmed. I don't like these videos being long. I planned on it being like 10 minutes. That's never going to happen. But how do you learn it? How do you get it better? Let's trend toward basic addition and basic subtraction. Basic addition means treat everything positive for as long as you can. Basic subtraction means big minus small. Then, or vice versa, let's also determine which direction we're going to end up. Positive or negative, right or left. If you start right and go further right, positive. If you start left, go further left, negative. The other one's positive or negative depends on the size of the values. If your negative number is larger than your positive number, no matter which side it's written on, if the thing attached with the minus is bigger, your result is going to be negative. If the thing attached to the plus is bigger, the result's going to be positive, and it's going to be like a subtraction because you're going opposite directions. You're trending towards 0 or possibly passing 0, in which case that's where you get the positive, negative, whatever. So you're seeing that idea. If we can get basic addition and subtraction in and know what the sign is, you'll be golden. And that's it. That's it. So I'm going to do 20 more problems, and I know it's like, oh my God, you only just did here 18 of them, and you took a half hour of my life. Let's try and speed it up, shall we? The only thing I'm ever going to write that's different, I'm going to say things. The only other thing I'm going to write is different is if there's a plus negative, I'm going to turn it into minus. And if there's a minus negative, I'm going to rewrite it as a plus. That's it. You ready? Let's go. Here we go. So, 20 problems. And I haven't seen these before. I didn't create these. I grabbed these from somewhere online, plastered them on. But they're all, I take back, they're not all single digit. Some are very small double digit. But it's okay. We can still do basic addition, subtraction with the numbers. Okay, number 1, 5 minus 8. It's like 8 minus 5. It's like 8 minus 5, but the result is negative. So this equals -3. 8 minus 5 is 3. Negative number was bigger, negative. It's a difference because different signs. Number 2, -10 plus 12. Positive number 12 is bigger, so it's going to be positive. This is like 12 minus 10. But it's negative. This is literally like 12 minus 10. I can rewrite this as 12 minus 10, but I said I wouldn't. I promised I wouldn't. If you want to, go ahead. Use the commutative property. Number 3, -5 plus 8. Just same thing as -10 plus 12. The 8 is bigger, positive, so treat it like 8 minus 5. That's 3. Whoopsies. Number 4, 3 minus 8. The negative number is large. You're subtracting something larger, so the result's going to be negative, but you started positive. Opposite direction, it's like subtraction. 8 minus 3, but negative answer. 8 minus 3 is 5. The answer is -5. Number 5, -8 plus 12. Once again, positive number bigger. Let's just do 12 minus 8. Just reverse them. 12 minus, it's like subtraction, positive answer. 12 minus 8 is 4. Number 6, -6 minus 5. Start negative, go further negative. Left, then left. This is like addition. It's like 6 plus 5. But the result is negative. 6 plus 5 is 11. Your answer here is -11. Number 7, -7 plus 2. Start left, go right, still negative. Not quite towards 0, but getting smaller. It's like 7 minus 2, but the answer is negative. 7 minus 2 is 5, so this is going to be -5. Number 8, -12 plus -5 is -12 minus 5. I said I'd rewrite these. And -12 minus 5, left then left, further left. Bigger negative number, like addition. 12 plus 5 is 17, but negative. This is -17. Is this okay? Let's keep going. Number 9, -3 minus 6. Left, left. I don't know if I have any positive pluses. I feel, but I guess because it's too basic, I'd rather us do the ones that this is fine. Number 9, -3 minus 6. Left, left. Bigger, like addition, but negative, because we stayed left. So this equals 3 plus 6 is 9, so -9. Number 10, -9 plus 11. Positive numbers bigger. This is subtraction. 11 minus 9 is 2. And again, it's subtraction,
because different signs, minus, plus. Number 11, 3 minus negative 2 is 3 plus 2. Oh, look, there's one. And let's not, well, just, right, bigger, positive. 5. Number 12, 7 minus negative 6, 7 plus 6. Oh, look, that happens a lot now. 7 plus 6, right, bigger, positive, 13. Basic addition. Number 13, treat as basic subtraction. Negative 4 plus 6, positive number bigger, so it's positive, it's subtraction. 6 minus 4 is 2. Again, just rewrite them. Positive 6 plus negative 4, 6 minus 4. Number 14, negative 2 minus negative 1. 3 negatives in here. Good God, what are we going to do? Let's start with rewriting this as a plus. Negative 2 plus 1. Left, then right, bigger negative left number. Bigger negative number. So it results negative, but it's like subtraction because opposite signs. 2 minus 1 is 1. We end up with a negative 1. Number 15, 2 minus negative 5 is 2 plus 5, which is 7. Number 16, 1 plus negative 3 is 1 minus 3. Negative number bigger, so the result's negative. It is a subtraction, so think 3 minus 1. 3 minus 1 is 2. We get negative 2. Number 17, negative 4 minus negative 4. Oh, okay, so I did run into one of these. Is negative 4 plus 4. Okay, same value, different sign. It's neither negative nor positive. You're cancel. I don't want to say cancel. The result is 0. This is the same as 4 minus 4. They're the same size. Same size, opposite signs, opposite directions. Go 4 left, then 4 right. You're back where you started. This result is 0. Now, because I don't see one, if it said negative 4 minus 4, that's going left and left. That's like 4 plus 4. That would be negative 8. Negative 4 plus 4, however, is 0. Number 18, negative 12 plus 4. Answer's negative. It's like 12 minus 4. Let's get negative 8. Number 19, 3 plus negative 10 is 3 minus 10. Negative value's bigger, so the result is negative. Opposite signs, it's like subtraction. 10 minus 3 is 7, so we get negative 7. And finally, number 26, minus negative 3 is 6 plus 3, which is 9. Okay, so that'll do it. Just as a general recap there, what I'm trying to hit home here, of course, is a lot. If we can treat these things like basic addition and subtraction, well, first of all, if we can rewrite it as only addition or subtraction, not have plus negative or minus negative, that's a good thing. Treat it like basic addition or subtraction when you can. When I say it's like, I mean it's not necessarily the answer. Negative 6 minus 3 is not the same as 6 plus 3, but it's like 6 plus 3. You should compute it because you get a bigger number. Anyway, so treat something as addition or subtraction when you're able to. Basic addition or subtraction. Know what your sign is supposed to be based on either which direction it goes and continues on, or which value is bigger when it comes to sign. And of course, if the values are the same, they nullify and become 0, like that negative 4 plus 4. But the rest of them, we shouldn't ever really have a concern on positive or negative. We should definitely know which one it is based on which value is bigger or which signs are the same each time. The other thing, treat it as addition or subtraction, is just, do I continue in the direction I was going, or am I going in a reverse direction? If I continue in the direction I was going, treat it like addition. If I reverse direction, treat it like subtraction. And that's it. Did I need 45 minutes to say that? Probably not. Now I kind of feel bad. But you know what? Why not? I have time to do it, so I thought I'd teach it anyway. The most basic thing that I can ever cover on this channel, covered in 45 minutes of time. So I hope that this video was worth your time for you. Maybe you skipped around and saw the example problems and all that. That's great. I appreciate you spending your time with me and making sense of it. Do some other practice problems on your own. You can just type in online integer addition, subtraction, practice. Hopefully you get other problems that look like this and you'll be set to go. Well, thank you for spending time with me, guys. I hope that this was useful, and please have a good day.